All right, let's take a second and talk about this problem of the day. You needed to convert that into degrees, sketch the angle, and then find the exact measurement of the sine of 5 pi over 4. Well, the first two actually kind of help lead you into number 3. So if I convert that, I multiply that by 180 over pi, and I get 225 degrees. Then I sketch that, and remember, I'm always going to start with the positive x-axis. Rotate around, halfway around rotation would be 180 degrees. I go another 45 degrees and get 225 degrees. So my reference angle right here is 45 degrees. Well, I'm thinking of that as a unit circle, so my radius is 1, and I've got a special right triangle, a 45, 45, 90 degree triangle. So my two sides are going to be radical 2 over 2. And I know it's negative because I'm going to the left and I'm going down. That ordered pair right here is going to be negative radical 2 over 2 all over negative radical 2 over 2. So the sine of that, move that over a little bit so it's a little bit neater. On a unit circle, my sine measurement is my y coordinate, which in this case is going to be negative radical 2 over 2. You could also think of that, because it is a right triangle, opposite over hypotenuse, which gives you the same thing. Let's go ahead and start our lesson. We've done trig using right triangles. That was our first lesson that we did. However, what we're going to be doing today is we are going into non-right triangles. And in order to solve those, we are going to need to use the law of sines or the law of cosines. Today we're going to spend our focus on the law of sines. And like all the videos that we do, today's date is today. I'm sure you guys are asking yourselves, gosh, I wonder what the law of sines is. Well, this is it right here. If you've got a capital A, B, or C, that is an angle measurement. If you have a lower A, B, or C, that is a side measurement. If you look on Canvas, there's going to be an optional quiz. It's an Desmos activity, which will help you derive the law of sines. That needs to be done before the test, and I highly recommend you give it a shot. It doesn't matter if you put the sign on top or in the numerator, down below in the denominator, as long as you are consistent. If you notice, we have 3 ratios here, but in order to set up a proportion, we're only going to ever have to set 2 of those up equal to each other. So you'll only need 2 ratios. All right. And this is just kind of saying what I just said. The lowercase are sides, the uppercase are the angles, and the side and the angle of the same letter are always going to be opposite of each other. Well, I know another thing you're probably asking yourselves is, gosh, when can I use the law of sines? Well, you can use it when you know 2 sides, 2 angles and a side, or 2 sides and a non-included angle. I don't want to ruin the surprise for you, but if you know 2 sides and an included angle, we're going to use the law of cosines. Something to look forward to next class period. So let's just take a second and practice setting up those ratios. So right now I've got 3 angles and they're already set up, and I've got 3 sides. So if I set this up, it's going to look like this. 5.7 over the sine of 28, because those are opposite. 12 over the sine of 101.5, because those are opposite. And 9.4 over the sine of 50.5, because those are opposite. What I think is kind of interesting is if you were to put this in a calculator, took 57 divided by the sine of 28, this is the answer you get. If you take this 12 divided by the sine of 101.5, this is what you get. 94 divided by the sine of 50.5, this is what you get. Take a second and kind of think to yourself, why the discrepancy? Well, it really comes down to rounding errors, okay? That's one of the reasons we try not to round until the very end. So, on this one, take a second, try and set this one up on your own. So the sine of, or the side of A is 123, and the angle opposite is 106. X, the angle opposite that is 13. And for the side of 112, the angle opposite that is 61. When I do this, I can set up, I've got a couple choices. I can set this ratio up right here, or I can set that ratio up right here. It doesn't really matter which ratio that I set up, and you might even want to take a second and try doing both of them and see if your answers come up to be the same. I think I'm going to do the second one just because it looks like I have a little bit more room to work right there. So what I would do is just multiply both sides by the sine of 13. So you're going to get 112 divided by the sine, sorry about the handwriting, of 61 degrees times the sine of 13 degrees. And at that point, it's really just going to be calculator work. So the way I would put this into my calculator is just order of operations. I'm just going to take 112 divided by the sine of 61. When I do that, I get like 128. And then I multiply that by the sine of 13. And when all is said and done, I get 28.8. And they don't have any units of measure of feet or anything like that, so I'm going to let it go right there. All right. Take a second and try this one on your own. And I just realized that I meant to hide that angle right there. Pretend you didn't see that. So hit pause, try that one on your own. Well, I'm not going to really go back and correct that little mistake that I made because I don't think it's a big one. I think everybody in here would have realized that that's going to be 75 degrees. The sums of all three angles of a triangle have to be 180 degrees. If I were solving this, that is where I would start. That means that I can eliminate two of these multiple choice questions right off the bat. I would eliminate B and C because they have the wrong Y measurement. So now I need to figure out my sides. And when I do that, that is the ratio that I'm setting up is 11 over the sine of 64 equals Z over the sine of 41 equals Y over the sine of 75. You're going to have to do two ratios here. The first one would be the first two fractions that equal to each other. The second one would be the first and the third set to each other. And remember, you're just cross multiplying. When you do that, you should get answer A. All right, everybody's favorite, word problems. We want to use the law of sines to find the lengths of the ropes. I looked at this tree and it looks like there's oranges growing on a pine tree, which seems a little weird, but I'm going to let that one go. So we know the angle between the two ropes at the top is 25. The length of the first rope, it looks like it's X. The second one is Y. We have to find that missing angle right there. Well, I know the 75 and that angle are going to form a straight angle. So that's going to have to be 105 degrees. You could also have added up the 75 and the 25 and subtracted it from 180. So when I do that, I'm going to go ahead and set up my ratios. To get the first one, I'm going to actually take these two and solve them, cross multiply. So that's just going to be calculator work. Actually, I don't have to even cross multiply on that one. I'm just going to take 20 divided by the sine of 25. And I should get 47.32. And then I'm going to multiply that by the sine of 105. And when I do that, I should get 45.7. Now, I'm going to go ahead and I'm going to set up and solve for y. And when I do that, what I'm going to do is set the first and third fractions equal to each other. So I'm just going to kind of pretend there's no giant space here and say that those two are equal to each other. So again, I'm just going to take 20 divided by the sine of 25, get 47.3, and then multiply that by the sine of 50, and I get 36.3. And you kind of want to ask yourself, does that seem reasonable? In my mind, it does, because the rope on the outer should be longer. If I hadn't gotten a longer rope, I'd probably go back and reevaluate and see if I did something wrong. All right, on this one, I'm going to let you try and solve X entirely on your own. Go ahead and hit pause. The three angle measurements are given to you, as well as one of the sides. You are trying to find the base of this pyramid. When you do that, you're just going to assume now that you've hit pause again and you want to see the answer. Just take 155 divided by the sine of 54.7, and you should get like 189.9, and then multiply that by the sine of 70.3, and your final answer should be 178.8. You round that to the nearest foot and you get 179. All right. We've done a lot of problems that deal with trees. What's kind of fun on this one is, hey, we've got a crooked tree this time. Everything else we've always done has been a nice straight tree. So this tree is leaning 10 degrees past vertical. You have to really kind of think about that, because if that had been vertical right here, that's going to be a 90-degree angle. Well, it's 10 degrees past vertical, so it's actually 90 plus 10. That's where they get that 100. So go ahead, hit pause. Let's see how you do. When you're ready to check your answer, hit pause again. You should get 10.9. One of the tricks here is actually getting this angle measurement with the tree, and it's going to be 42 plus 100, which is 142. Subtract that from 180, and that's where the 38 comes from. All right, one of our other objectives was to find the area of a triangle. This is just a straightforward plug and chug type of formula, so I'm not going to spend a lot of time with that. There's actually 3 formulas here, but it's all basically the same thing. You need to know 2 of the sides and the angle between the 2 sides. So you need to know 2 sides. So if I know B and C, I need to know angle A. If I know sides A and B, I need to know angle C. If I know sides A and C, I need to know angle B. I don't really pay attention to the formula very much. All I do is really think about, do I know 2 sides, and do I know the angle that is between them? Having said that, I'm going to let you try this one entirely on your own. At this point, I'm kind of hoping that you can do the straightforward problems. So go ahead and hit pause. Let's see how you do. All right, when you do this, you take 1/2. My sides are 39 and 52. So 1/2 times 39 times 52 times the sine of 25.89. And you should get 442.8. I probably should have put inches squared. All right, that's all I have for notes on this. If you need some more help, come into IPASS or come see me. We'll talk about this more in class. I know I went through some of this pretty quickly, but I have faith in you. All right, enjoy.